Hi grade 12s. So I'm going to be explaining the relationship between f, f dashed and f double dashed x. So what I'm going to do here is I'm just going to highlight some of these things. So I'm going to highlight the f dashed as red. So this is going to be this graph here. Then we can do the f in green. And that's going to be this one here. And then we've got the last one, f double dashed, and we can do that in orange. Okay, so I'm not really interested in what equations they've given us there. I'm just going to discuss the relationship between these three things. So if I look at the green one, the original one, okay, I know that I have a turning point over here. Let me do it in here. We have a turning point over here, and we have a turning point over here. Now, if I look at the first derivative, now just remember that our gradient here is 0 and our gradient here is 0. So that means for the derivative graph, f dashed x, that means that our x value or our y value will be 0. So have a look here. We have a turning point. That means that we have an x-intercept for our f dashed. Here we have a turning point, and again we have an x-intercept over there. Now another thing that I want you to notice here is the gradient of our original one, the green one. The gradient here is positive. So that's positive, 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 positive. And I'm just going to highlight that because you probably can't see. So it's all positive here, positive gradient. Then, as we pass this turning point here, we get a negative gradient for our original graph. So these are negatives. Then, from this turning point onwards, we have a positive gradient for our graph. Okay. At these 2 points here, our gradient is 0. Okay. So, why did I show you guys that? Because here our gradient is positive. Then what I want you to notice up to that point there, if we look at the f dashed graph, which is this red one, our y values for that are positive. Okay, so gradient positive, y values positive. Then 0 gradient, x-intercept. Then from here to here, we have a negative gradient. So that means for the first derivative graph, the red one, have a look here. All our y values are negative. From that point up to that point there, you can see all the y values are negative. Then, as we pass our turning point, which the gradient is 0, so x-intercept, our gradient becomes positive again, so our y values there are all positive. Okay. What I also want you to notice here is we have this turning point over here. That turning point for our first derivative will correspond to the point of inflection for our original graph. Okay, now let's have a look at the relationship between our f and our f double dashed. So first things first, we have a point of inflection. So that means that it's going to be the x-intercept for our second derivative. Because remember, how do we find points of inflection? F double dash of x equals to 0. And that's exactly what that is. So we have a point of inflection at -1 and our y value is 0. Okay. Then let's just make a note here as well. So this was f dashed x equals to 0, and that's why that one's 0. And then likewise over here, f dashed x equals 0. Okay. So we now have this point of inflection, which is our x-intercept for our second derivative. Now, if you have a look here, the concavity. So concavity ends and starts at your point of inflection. So from there to there is one concavity, then it starts again from there to there. So from here to here, we have concave down. Now remember, for concave down, f double dash of x is less than 0. Okay, so concave down, our second derivative is 0. So have a look up to a point of inflection, which is 0 for our f double dash, and concave down. Have a look here. All our y values for that orange graph are negative. Okay, concave down. Then from here onwards, we have concave up. So for concave up, f double dash of x is positive. So we're expecting the y values for our second derivative to be positive over here because this is concave up. So let's go here and have a look. All your y values are positive from that point on. So that means concave up because y values are positive. This means concave down because y values are negative. Okay. Now let's have a look at the relationship. So we've discussed the relationship between f dashed, f, and f double dashed. Let's have a look at the relationship now between f dashed and f double dashed. So turning point for your f dashed is the point of inflection. So that's going to be an x-intercept. Now from this point onwards, you can see that our gradient for our first derivative here is positive. Okay, we've got a positive gradient. So that means that the graph is increasing. So we're expecting from this point, which is that point there, onwards, that our y values will be positive for our second derivative. And you can see they are positive. So all those y values are positive there. Then from this point onwards here, you can see that the gradient is negative because the graph is decreasing. So we are expecting the y values from this point onwards for our second derivative to be negative. And you can see there they are negative. And guys, that is the relationship between those three. Okay, so you can just read your notes there. It pretty much says the same thing as what I just explained. What I am going to do is I'm going to be going through this example here, example 5. So it says here the equation of the curve is given by f. Let me just put this down so we can get some work here. So it's saying here that the equation of the curve is given by f of x is equal to ax cubed plus bx squared plus cx. We need to prove that a is 2, b is minus 9, and c is 12. So what they've given us here is they've given us the f dashed graph, okay, the first derivative graph. So now remember what we've got here. We've got the first derivative. So what this means that over here and over here, we've got the x-intercepts. So that means that these 2 points here, remember what we've drawn? F dashed of x equals 0 at both these points. That means we've got turning points. So our one x value for our turning point is 1. The other x value for our turning point is 2. Okay. And then over here, we've just got a random point, which is 0, 12. Okay. So let's have a look at question A. We've got f of x is equal to ax cubed plus bx plus cx. What I'm going to do, grade 12s, is I'm going to differentiate this thing. And the reason why I'm going to differentiate it is because I have my first derivative graph. So all of this information in this graph relates to the first derivative, not to the original one. So let's differentiate this. F dashed x is equal to 3ax squared. Sorry, that's squared there, plus 2bx plus c. Now, I'm going to use my 2 turning points here. So I know that f dashed of 1 equals 0. Okay. F dashed of 2 equals 0. Now, I know they're going to be equal to 0 because they are turning points for the original graph. I'm just going to substitute the 1 in here, equal it to 0. Substitute the 2 in here, equal it to 0. So we get 3a1 squared plus 2b1 plus c equals 0. And then this one here, we get 3a 2 squared plus 2b2 plus c equals 0. I'm just going to simplify this out. So we get 3a plus 2b plus c equals 0. That's going to give us 4. That's 12a plus 4b plus c equals 0. Now, we've got a bit of a problem here, grade 12s, because we've got two equations, but we have three unknowns, a, b, c, a, b, c. So we can't solve this as it is because we only have two equations, three unknowns. So I need to find another bit of information that will help me get another equation. And that's where this point comes in. Okay, so we're still dealing with the first derivative. So with this point here, I know what I can say is I can say that f dashed of 0 is equal to 12. So basically my coordinate, 0 for x, 12 for y. Okay, and what I can do now is I can substitute that into here. So we get 3a 0 squared plus 2b 0 plus c equals 12. That just means that c is equal to 12. All right. What I'm going to do with this 12 is I'm going to now replace it in here and here. So this equation now becomes 3a plus 2b plus 12 equals 0. And this equation becomes 12a plus 4b plus 12 equals 0. So now what we have there is we have two equations, two unknowns, AB, AB. So I can use simultaneous equations. I'm just going to work with this equation and solve for B. So 4B is equal to minus 12A minus 12. Divide through by the 4. And we get minus 3A minus 3. I'm going to take this B value and I'm going to substitute it in here. So this equation here becomes 3a plus 2 times minus 3a minus 3 plus 12 equals 0. So we get 3a minus 6a minus 6 plus 12 equals 0. Okay, so that'll give us minus 3a. That'll give us 6, take it to the other side, becomes minus 6. So a is equal to 2. All right, I'm now going to take that 2 value and I'm going to substitute it in here where a is to get the b. So b is equal to minus 3 times 2 minus 3. So b is equal to, that's minus 6 minus 9. All right, so we have our c is 12, a is 2, b is minus 9. So a is 2, b is minus 9, c is 12. And that's what they wanted. Okay. If we now look at question B, 1. They're asking what is the y-intercept. So all I'm going to do is I'm going to substitute the a, the b, and the c back into this main equation here. So we get f of x is equal to, a is 2. So we get 2x cubed minus 9x squared and then plus 12x. So for the y-intercept, we just make x 0. So y is equal to 2, 0 cubed minus 9, 0 squared plus 12, 0. So we get y is equal to 0. That is your y-intercept. Then the x-intercepts. To find the x-intercepts, we just make y 0. So we set this thing equal to 0. Okay, so what I'm going to do here is I'm going to take out a common factor of x. And we're left with 2x squared minus 9x plus 12 equals to 0. All right. Now, this thing here might not be able to factorize. So what I'm going to do is I'm just going to use my delta. And if you guys don't know what that is, delta is equal to b squared minus 4ac. You have seen that before. It's nature of roots. Now, guys, you don't have to write this down. This is just to help me check if this thing is factorizable. So what is our b? It's minus 9 squared minus 4. A is 2 and c is 12. Now, if this thing comes out to be negative, that means that this can't be factorized because it means non-real roots. Okay, so we get minus 9 squared minus 4, 2 times 12. And it's negative. That means you cannot factorize this trinomial, okay? So that only leaves us with one solution. So we just have x is equal to 0 because this cannot be factorized. Right, then question 3, the coordinates of the relative turning points. Now, to find turning points, we normally just differentiate this and set it equal to 0. But I'm going to cheat in inverted commas. I already know the x values for my turning points. They're going to be 1 and 2 because I have the first derivative graph. So all I'm going to do is I'm just going to find the y values for them. So I'm going to take that x value of my turning point, put it into this. Take that x value for my turning point, and then put it into that to find the y value. So f of 1 will be equal to, and I'm just going to put it on the calculator, guys. So we've got 2, 1 cubed minus 9, 1 squared plus 12, 1. Sorry, let's do that again. So we've got 2, 1 cubed minus 9, 1 squared plus 12 times 1. And we get a y value of 5. Okay, now I'm going to do it for the other x value, which was 2. So we just put 2 in here. So f of 2 gives us 4. So the coordinates of our turning points are going to be 1, 5. And for this one, 2 and 4. All right, next question. Sketch the graph of f. Okay, so now we have all our information that we need. Question C. I'm just going to draw a little rough one here, guys, just so that you can see. First of all, we know that we have a y-intercept of 0. We also have an x-intercept of 0, which is on the same spot. Now, just going back to the original one here, just remember that this a value being positive means that my general shape is going to look like that. All right, so that's the type of shape I'm looking at. Then we've got a turning point at 1, 5, and then we've got another one at 2, 4. Okay, so it's going to go through this point here. It's going to turn here, come down, turn, and then shoot back up. And that is our graph. Okay, then grade 12s, I've done these videos for you on YouTube already, so you can just have a look for those ones. All right, guys, good luck.